Hello, today I will be going over the 2020 CodeChef June Long challenge problem number 5, which is even matrix. To summarize the problem statement, you're given an integer n and you're asked to create a n by n matrix such that for any a by a subarray in the matrix, the top left number plus the bottom right number is even and the top right number plus the bottom left number is even. You must return this matrix. So let's go over what the conditions mean. So let's say, for example, given a number n equal to 3 and the matrix as shown, we can create different subarrays. So first we have to check 1 by 1 subarrays. A 1 by 1 subarray would just be one singular element. We check the top right and bottom left elements, which are both just the singular element, add them up, and see if we got an even number. We do the same for the other two pair of diagonal elements, which is also just the same element. We add them up and we check if that's even. So in a 1 by 1 subarray, it will always be even for all diagonals. Therefore, we don't actually have to worry about this case. But let's look at a 2 by 2 subarray. So here, if we pick any 2 by 2 subarray, we have to check through all of them. But let's just say we pick this one over here. We can compare the diagonals. So one diagonal, which we can see, is 1 and 5. We check 1 plus 5 is equal to 6, and that is even. The next diagonal we can check is 2 and 4. We add 2 plus 4, that is 6, which is also even. So we just do this for all 2 by 2 subarrays in there. Next, we check the 3 by 3 subarrays, do the same thing. We will check 1 and 9, that is 10, 3 and 7, that is also 10, both of them are even, and we'll just keep doing this for all a by a subarrays. And we will go through all a by a subarrays that could be found in the n by n matrix. So now let's go over the solution using a coloring approach. If we start out with any n and want to create an n by n matrix, we can start filling in the matrix based on the parity. For example, with n equal to 3, we can see that. For the odd numbers, if we let the left topmost number be odd, then in that case, we would see that the bottom rightmost number would also have to be odd in order for the 3 by 3 subarray to be even, for the odd plus odd to be even. But in this case, we would also need the centermost element to be odd, so that these two elements can become even. In this case, we can do the same approach, labeling all the elements as odd and making all possible pairs. And in this case, we can label all elements that have to be odd if the top leftmost element is odd. And then we see that the remaining elements all have to be even in this case. And we can double check this. We see that even plus even is even plus even is even, and so on. So we see that this is already a working solution for a 3 by 3 subarray. So we can just implement this, and for all n, we can just tile a matrix in this format, going odd, even, and so on. So one very simple way where we can tile it is just by using the numbers 1 through n itself. For example, for n equals to 3, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9. However, if we look at 4 by 4 matrix, for example, so in this case, if we let the topmost element be odd, we know that all the elements in its diagonal must be odd. So in that case, we have one odd pair for a 2 by 2 matrix, another odd pair for the 3 by 3 matrix, and a fourth odd pair for the 4 by 4 matrix. Then we can also see that in this case, we can fill in the remaining odd elements for the 2 by 2 matrices. So now we have all the odd elements labeled out. But now if we take a look at the even elements, you can see that if we place an even element here, we can label the other even elements in order to create a working 2 by 2 subarray. And if we continue labeling all the even elements, we'll notice a different pattern. It goes odd, even, odd, even, but then even, odd, and then back to odd, even, and then even, odd. So we see that it alternates. Between every two lines of this, the even element gets put at the front instead of being an odd element. So this too is a very easy thing to program. And for example, if we have the n numbers 1 to 16 in this example, we can just write it out as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. As simple as that, and we have our arrangement for an even n by n subarray. So now we have two very simple constructions which we can use if n is odd or n is even. And now we just need to program both of these, and we have our solution. Now let's go over the code implementation of this solution. So we're going to start out with our integer t, which is the number of test cases, input into it, and then for each test case we're going to run our program. Inside here we're going to input our n, and then we're going to set a counter equal to 1. This counter is basically going to print out the numbers from 1 to n. So in the first case, we have if n mod 2 is equal to 1, or if n is odd. We're just going to have two simple for loops to print out the numbers in order, as we saw in the pattern. Now let's say n is even. Then we want to do something slightly different. We're still going to have two for loops, however, we need a check, because we have one regular printout of numbers, but then the second row, the numbers are going to be reversed. Then the third row is regular, fourth row reversed. So we need to keep track every single time we switch. We can do this by keeping a counter to see if I is even or I is odd, or we can just directly write out the statement. Here we want to run a for loop that's just going to print out a regular line. If not, then we want to print out the line backwards. So we can do this by creating an integer array, storing the values, and then printing out that array backward. And then afterwards you can print out another end line. Submitting this, we see it is accepted.